All right, let's do this here. Linear approximation. Okay, the whole principle of linear approximation is you're using a tangent line instead of the actual function. And however you want to write that down in your notes, I suggest you doing it, using your own words. You don't have to write it down if you understand it, me just saying it, but it's the whole basis of it is using a tangent line, which we've done in Unit 2. We did equations of tangent line. It was on your test. You got a bunch of those types of problems, but you're going to use that tangent line equation rather than the real original equation. Okay? Crazy. All right. So I'm going to restart the numbering. I hope that's okay with people because I started a new section. Okay, so number 1. All right, I'm going to give you certain facts. And using these facts, you need to figure out a local linear approximation for a specific value of f at x equals 5. Okay, so certain things I'm going to leave out of here that AP will not leave out, but that's just because I'm not AP and they go overboard on stuff, which is good. You want to go overboard on this stuff. But I'm going to say a differentiable function. I'm just going to say it though. I don't feel like writing that. Has the following properties. Okay, the following properties are f of 5 is equal to 3. Okay, f prime of 5 is equal to 4. And we are looking for what is f of 4.8 equal to using the information. So I'm going to put a little line right here. So using the information over here, what can you approximate? Oops, so I should have used the approximate symbol. My bad. So using the fact that we know that f of 5 is 3 and f prime of 5 is 4, we want to figure out what is f of 4.8 approximately. Okay, using the information that we already have. And I'm going to tell you right now, AP would say this, f is differentiable, meaning there is a derivative, it exists everywhere in its domain. Okay, you don't really need that. So when you read a problem and it says a differentiable function f has the following properties, find the approximation of f of 4.8. Okay, I just didn't want to write differentiable function for f. Yeah. What did you get? Nope. So that's it. That's the answer to your question. For linear approximation, you need an equation of a tangent line, okay? Which means you need a y equals mx plus b for this approximation. We don't even know what f is, okay? We don't actually need to know what f is because we figure out what the m is based on right there. The m is 4. It says f prime of 5 is 4. That means the slope is 4. So let's start building that linear approximation equation to use it. And then we're just going to throw in 4.8. Okay, I use L of x because that's what's used a lot on the internet for linear approximations. They use L's. When you are in Calc 2 Taylor series approximations, or I should say Taylor approximations, you will use capital T for Taylor. I think, I don't really know, but it is T. So we're going to use L of x for linear. And we need a mx plus b for this equation. Now, sometimes you'll see on my answer keys, I use y equals mx plus b. It doesn't matter. Okay, it does not matter if it's y or if it's L. It's whatever variable you are comfortable with. But let's start creating this linear approximation equation so that way all we have to do is throw in 4.8 and we call it a day. Okay? Does everyone understand what we're trying to do? Okay, we're trying to find a line equation and then plug in 4.8 based on the information that's given. So here we go. We know that our m is right here is 4 at 5. Okay, if you remember I told you before, whenever you use a linear approximation, it has to be close to whatever value you have. So we have 5, we're looking for 4.8. 4.8 is pretty close to 5. Okay, so let's make that whole equation here. So we're going to have L of x is equal to, okay, you plug in 5 here. Well, you don't need to plug in 5. 4 is the slope. So now we have y equals, or L of x equals 4x plus b. But we need to figure out b. How can we figure out what B is? Go. Yep, so we're going to plug in 5 for X, and what are we plugging in for Y? Three. Thank you, whoever said that. All right, so then you're going to have 20 here, so B is going to be equal to negative 17. So now you have your full equation. You have L of X to be equal to 4X minus 17. Hold on, I'm seeing if this is a calculator. I didn't write it down. I doubt it's a calculator problem. All right, now that we have our linear approximation equation, now we can figure out, that's embarrassing, what L of 4.8 is, because it's going to be approximately equal to F of 4.8 is equal to 4 times 4.8 minus 17. And that is 16 plus 3.2, so 19.2 minus 17 is 2.2, I think. So can someone check? Or did someone else just do it in their head already? Is it 2.2? All right. Then you get 2.2. All right, do you understand what you did wrong when you guessed 3.2? Yeah. Okay. The main thing is you're using a line equation to figure out some value rather than the actual F equation. F's not even given in this. We don't know what it is. We know one value of it, but we don't know what F is, so we can't even figure out if we want it. Now, is this a real life thing? No, this is stupid. I'm sorry, I shouldn't say this is stupid when I'm being recorded. This is silly. It's not a real math thing. It's not like you're going to give things like this. It's just a riddle. It's like a math riddle that you're trying to figure out based on certain other information. Okay, when you're an engineer or scientist or whatever you want to do when you grow up, you're not going to see a problem like this. You're not even going to see anything really related to this that much. You might see a rate of change, but you're not going to see something set up like this. Doesn't mean that it's not important. It's just, that's what I mean by silly. Okay, number 2. Actually, you know what? I am going to give the one that I originally wanted to give because I want to see if you can do it on your own. It's just good practice. Oh, wait, actually, this is kind of a trick. This is good. This is really good. Sorry. There we go. Okay, work this out. Try to do it without using your notes, but if you aren't there yet, then use your notes. That's right in front of you. Okay. The main thing is you need to make an L of X equation. And you're just going to plug in 0 to it. Okay, this one's weird. This is throwing you into the deep end. It's okay. You definitely can do it. We went over enough of this stuff for you to go over it or to be able to solve it. It's just you might have to look at your notes if you haven't fully understood everything we're doing here. Or this might be really super easy. All right, I'm going to tell you this is twice differentiable because that's what AP would tell you. Okay, also, we're going to be dealing with the second derivative on this. It's going to be crazy. Here we go. I'm going to tell you what's true on this. When in doubt, graph it out. Oh man, this is so crazy. I love problems like this. All right. And then justify your answer for this. It goes without saying, but I'm just going to write it in there anyway. Justify your answer. If you ever see that on one of your tests, JYA, that means you didn't show work. Justify your answer. You have to explain what you did. When in doubt, graph it out. This is crazy. I love it. Here we go. First step is to find L of x, just like we have been doing. So L of x is equal to, well, in this case, the slope is 4, so it's going to be 4x plus b. Okay. We're going to use the original, the f of 2 is equal to 1, the original f equation, the non-derivative, to figure out what that b is. So b is equal to -7. So your L of x equation is L of x is equal to 4x minus 7. You have to plug in 1.9 because that's what we're looking for. Which is going to be 4 plus 3.6, so 7.6 minus 7 is 0.6. So that's the answer for the first part, for the approximation. Now it says, is it an overestimate or an underestimate? Well, I gave you a little bit of a clue earlier when I was talking about it. So if you're really paying attention, you might have gotten the clue. But I said, when in doubt, graph it out. So it says f of 2, let's just say this is 2 here. Let's say this is 1, is right here. Okay. It has a positive slope, so it's going to be increasing here, which I guess you have to pay attention for that too. Also, you have to pay attention that it is concave up because the second derivative is positive, which is crazy. So I'm just going to draw a generic concave up equation. It doesn't really matter how you draw it, as long as it's concave up at 2. Okay, 1.9 is a little bit less than this, so I guess it really doesn't really matter. Let's just say if we were drawing a tangent line, I don't know, it could be like right here. I drew this kind of weird. Oops, that's the worst tangent line in the history of time. Let's just say it's right here. Boop. Okay. You'll notice that because it's concave up, the orange is always going to be underneath it. Okay, the approximation is always going to be underneath it. So because it's underneath it, it's going to be an underestimate. So the answer for this one would be, is this an overestimate or an underestimate? You should say underestimate. And the justification that you can use that AP would allow is saying underestimate because f of x is concave up. You're supposed to say upwards, but they always write upwards on their answer keys. But I'm going to say concave up at x equals 2. And that is allowed for the justification because it's concave up automatically. The linear approximation is underneath it. You don't have to say that though. You don't have to say the linear approximation is underneath it. By the way, if you did not draw your concave up like that, that's totally fine. You did not have to draw it the way I did it. Okay, it'll still be underneath it no matter what. Okay? Even if you did, like, say you did it exponentially instead of mine's more of a quadratic. If you did it exponentially, it's still going to be underneath it. Okay. Okay. About as hard as these are going to get is that over/underestimate thing. These usually show up on free response problem, free response parts of tests as well.